So in this video, we're gonna continue with the idea of integration by partial fractions, and this is a linear one just to be straight up. The other one is gonna be quadratic. So if you're very comfortable with linear factors, you could just skip the video and move on to the quadratic one that I'm gonna do next. Okay. And so the idea for this one is that, again, it looks to me as if the bottom is factorable, so I could rewrite this as integral of x plus x 11x plus 17 over, what are my factors? X plus 4 and 2x minus 1 dx. Okay, so if I split this up, if I split this up and multiply, I'm going to skip a couple steps here since I've been doing it the long way. Well, essentially I'll get 11x plus 17 on the top, and that is going to be equal to a times 2x minus 1 plus b times x plus 4. Okay, now the idea is if I look at this, I could cancel out a. So if I set x to be equal to 1/2, then essentially I have 11 times 1/2 plus 17, and that is equal to 0. Okay, this will cancel out. 2 times 1/2 is 1. 1 minus 1 is 0. 0 times a is just 0. Plus, well, b times 1/2 plus 4. Okay. So if I treat this as, we know this is 11 over 2 plus 17 over 2. If I multiply by 2 on both sides, okay, that's going to equal to b. Well, 1/2 plus 1/4, that's just 9/2. Okay, that is just 9/2. And so if I simplify this more, this looks to me as that 2 times 17 is that plus 11. So this looks to me as if it's 45 over 2. And if you want to solve for b, all I do is multiply by the reciprocal on both sides. So I'm just multiplying by 2 over 9. Okay, and this looks to me as that 2 times 45 is 90. 45 divided by 18 happens to be 5. So therefore, in this case, we know that b is equal to 5. And so what is the next trick? If I set x to be -4, then I could get rid of b. Well, yeah, I could get rid of b to solve for a. Okay, and so if I set x to be -4, then this becomes 11 times -4 plus 17, and that is equal to a times 2 times -4 minus 1 plus 0. Okay, -4 plus 4 is 0. 0 times b is just 0. Okay, and so if I look at this, this becomes -44 plus 17, and that is equal to 2 times -4 is just -8 minus 1, that happens to be -9a. So this is -9a. And so if I add these together, -44 plus 17, and I divide by 9, I'll get my a to be what? 3. So in this case, my a will be 3. And so if I look at my integral will be the integral of a, which is 3, over, we decompose it. So this should be a over x plus, this would be a over x plus 4. This would be a over x plus 4, plus b, which is 5 over 2x. So it should be 2x minus 1 dx. Okay, guys, and I just skip. So this is 2x minus, it looks horrible, but 2x minus 1. Again, guys, I skip steps here. Okay, so I did not decompose. I just went straight on to factoring it. But if you guys did not know, I decomposed a in my head over x plus 4. Okay, so a over x plus 4, and then b over 2x minus 1. Okay, so I just want to get that straight of how I got this. And so if I'm looking at the integral now becomes 3 times the natural log of absolute value of x plus 4 plus 5 times the natural log of absolute value of 2x minus 1 plus c. This will be my integral. Okay, so now we're done looking at linear factors. Let's look at something quadratic. So what if I wanted to integrate 12x plus 4 divided by x plus x cubed dx? Well, to me, before I even start looking at my integral, I'm going to try to simplify the bottom. Okay, that's my first goal. And so if I'm taking a look at this, well, I know that this is equal in magnitude to the integral of 12x plus 4 over, if I factor in x, this becomes x times x squared plus 1 dx. Now I want to be very careful here and thorough. Notice that x is a linear factor. This is not. This is not factorable. Okay, b squared minus 4ac is actually less than 0. And so if I'm looking at this, I can rewrite this as 12x plus 4 over x times x squared plus 1. And I'll decompose that into a over x plus, here it just gets tricky. Because this is a linear factor, this is how we treat it. I'm going to say bx plus c divided by x squared plus 1. Okay, so you got to have this form here. Doesn't matter the variable, but you got to have some variable times x plus a constant. Okay, so this even could be d. This could be, ex, ex plus f. It doesn't matter. It has to be in this form if we're dealing with quadratic factors. Okay, and so the idea now becomes, well, if I multiply by x times x squared plus 1 on both sides, yeah, so this becomes x times x squared plus 1. This becomes x times x squared plus 1. Well, notice I have an x squared and 1 here, I have an x squared and 1 here, so these will cancel out. So I'll only leave with an x. And here I have an x, so only leave x squared plus 1. And so this becomes 12x plus 4, and that is equal to a times x squared plus 1, okay, plus bx plus c, okay, bx plus c multiplied by x. Okay, so hopefully we get this. The only thing I did there was just factor, just multiply whatever is given there. Okay, and so now I want you to take a good look at this. Now that we're not dealing with, well, we know that this is linear. Well, in fact, it's actually not, because we have a quadratic there, x squared. We're going to distribute that x. But the idea is that equating coefficients, that trick that we did earlier with linear factors, does not work for this. Okay, and so the idea is that whenever you deal with quadratic factors, I don't want you to do that. That is just plain old wrong. And so always do it the way that I'm doing it right now. You know what I'm saying? Just look at it from this path. I'm gonna multiply I'm gonna distribute my x. So this becomes 12x plus 4, and that is equal to a times x squared plus 1 plus, if I multiply that, that becomes bx squared plus cx. Okay, now the idea is I'm going to distribute my a. Okay, and so if I look at this, this becomes 12x plus 4, and that's equal to ax squared plus a plus bx squared plus cx. Okay, so therefore, now here's the idea. I have an ax squared. I'm going to group common terms. So whatever has an x in common, I'm going to group them together. Whatever has just a plain old constant in common, I'm going to group them together. Whatever has an x squared in common, I'm going to group them together. So 12x plus 4, that is equal to ax squared plus bx squared. They're common, so I'm going to group them together. And hopefully we could see that this is totally different from this. We have an x here. We have a is just a constant. So we have cx plus a. And these two are their own groups. Okay. And so if I look at this, the idea is, and let me factor it out first. So this becomes 12x plus 4, and this is equal to a plus b times x squared. So the only thing to do is just factor out my x squared. This becomes c times x plus a. Okay, there's nothing to factor out with these. And so the idea is whatever is in the parentheses that has this x squared here on this side has to be equal to the coefficient on this side that has an x squared. It so happens that we have no x squared term on this side, and so the idea is that a plus b will actually equal to 0. Okay, now we have c, it has an x in front of it. We have 12, it has an x in front of it. And so the idea is the coefficients are going to be equal. And so in this case, I know c is going to be equal to 12. Okay, here's your x in common, there's your x. Okay, and then the idea is that notice that a is a constant. So a is a constant, and we have a constant term here, so therefore a has to be equal to 4. Okay, now we have some problem, it gets more complicated where we actually have a system with systems of equations, and we're going to get to those. Okay, and so the idea is that we have all this in common now. Well, if I know that a is 4, then I could simply find b. If I plug in 4 in for a, then hopefully we can notice that b will be equal to -4. And so the idea is that if I plug in 4 plus b is equal to 0, then b has to be -4. And so we found b, we found a, and we found c. Okay, and so what is my integral now? Well, in this form, the integration will be equal to, so the integration will be equal to the integral of 4, which is a, 4, which is a over x, okay, plus, well, we have bx plus c. Well, what is b? B happens to be -4. We have our x, and then we have a plus c here. Well, what is our c? Our c happens to be 12. So this will be 12 over x squared plus 1. So it becomes x squared plus 1 dx. Okay, so this is how we get it in the form. Okay, now hopefully by now we should notice that this is a 4. So if I bring out a 4, this becomes a natural log of the absolute value of 4 times x plus 1. 4 times the natural log of the absolute value of x. Okay, but what about the integral of this? And before I even do that, okay, let's distribute our integral sign. So the integration in this case will be given by 4 over x plus the integral of -4x plus 12 over x squared plus 1 dx, and there's our dx also here. Okay, well, notice that this is also, it's difficult, right? Like you're looking at, well, what is the integration of this? And here's the idea. We actually will split this into 2, where one will become u substitution and one will become tangent inverse, okay? And so how we treat this is that we distribute the integral sign to both of these terms, both of the numerator terms on the top. So if I'm looking at this integral will be given as the integral of 4 over x dx, okay, plus the integral of 4x over x squared plus 1, okay, and this is -4x, okay, plus the integral of 12 over x squared plus 1 dx. Okay, and so that's how we treat this integral. We split it up into 2 by distributing the integral sign equally between the numerators, and we bring our denominators with us. Okay, and so if I factor out a constant on both sides, my integral will be given as the integral of 4 over x dx minus 4. Okay, so again, all I'm doing is taking out my constants. This will be -4 times the integral of x over x squared plus 1 dx plus 12 times the integral of 1 over x squared plus 1 dx. What we should recognize by now is that this is the integral of tangent inverse. Okay, what about this? Well, this is u substitution. And so if I set my u to be x squared plus 1, then my derivative is actually 2x dx. I have an x dx and not a 2x dx. So if I divide by 2 on both sides, well, 1/2 du is going to be x dx. And so if I continue with my integration, okay, if I look at just this part, well, this becomes the integral of 4 over x dx minus 4 times, well, this will be 1/2. I'm going to have my 1/2 here because 1/2 du substitutes for x dx. And there's my du, so there's my 1/2 du that substitutes for x dx. And essentially I have 1 over u. Okay, so hopefully everybody could see that. My 1/2 du substitutes for x dx, and this whole term was my u. Essentially I have a 1 on the top. And so that's my integral for the middle term. If I look at this, this becomes 12 times the integral of 1 over x squared plus 1 dx. Okay, and we should know by now that this is tangent inverse. So taking a full integral, this becomes the integral of 4 times the natural log of the absolute value of x minus, I could simplify this, so this becomes 1, this becomes 2, so this becomes -2 times the natural log of the absolute value of u. In this case, u is x squared plus 1. X squared plus 1 plus 12 times tangent inverse of x plus c. Okay, and this is my complete integral. So hopefully everybody see how I got to that part. Okay, I split my integrals up. This was u substitution. This was just tangent inverse. I just bring my coefficients with me.